The horn circuits, although a simple device in nowadays late model systems, it is also controlled by a computer. And the reason for that is because the anti-theft alarm system is many times tied into the actual horn itself. And remember that also the path of the horn contacts also go through the actual SRS clock spring, or the airbag clock spring. Keep that in mind. In this particular case, we see that this motor is actually fed power or voltage source through a relay, which in itself is controlled by the body control module. This body control module may also serve as the actual anti-theft alarm system, because the anti-theft module it's contained many times within the actual body module. We also see that in this particular case, the ground is directly tied to the horn itself, and the computer actually controls the coil side of the relay itself. And by controlling the coil side, the relay is actually, and this is a mechanical relay, the relay is activated and the horn will make a sound. Again, this is not a high-speed control, since the actual body module is interested in turning the horn on and off, and a relay is sufficient for this type of operation. This is not a duty cycle control device, in other words. So if it were, you would need a transistor or a driver in between, and this would probably be an internal module function. Again, this is the importance of a horn circuit is important, because many times you actually have to troubleshoot the actual data path that has to do with the anti-theft system. Here we see how the actual horn switch goes through the in yellow here goes through the clock spring, and a actual signal or a ground pulse is fed into the actual body control module itself, and this generates a electron path through the red current flow side, which activates the relay, and in turn actually activates the horn. The horn is actually activated by the relay, and the relay is activated by the actual module.